Continuing in Mod 6, in Example 5, on problems H through K, there will be an argument of AX, some number times X. So you'll see something like the sine of 4x or the cotangent of 3x. Because there is a coefficient in front of the x, we're going to have to solve them using a slightly different technique. What you are going to do is start out by solving until you have the function equals a number, like we were doing in problems A through G. Then you will find what angle has that value for whichever trig function. Then you're going to set that argument, the 4x or the 3x, whatever your AX is. You're going to set that argument equal to your angle measure. And you're going to then add plus 2k pi or plus k pi. What this does is allow for every possible angle that would meet that requirement. We're going to use 2k for everything except tangent or cotangent. For tangent or cotangent, you're going to use 1k. Once we finish, we will figure out what angles are between only 0 and 2 pi. So once you have argument equals angle, you're going to solve for x of the argument. You have to also make sure that you multiply or divide the 2k or the k by whatever number you have to use to solve the argument for x. Once you've done that, you're going to need to find a common denominator and find all the angles that are between 0 and 2 pi. I know this sounds very complicated right now, but once you've seen a few examples, hopefully it will make more sense. So the types of problems that we are going to look at will have the directions solve the equation over the interval from 0 to 2 pi. Example H is a very basic one of these problems, just to show you the idea of what we are going to be doing. Just like we learned on the earlier problems, the first thing you want to do is get the function by itself. So we are going to subtract 1 on both sides and now have sine of 2x equals -1. At this point, we have function equals number. So this is where we go to the unit circle and think about what angle has a sine value of -1. That happens at 3 pi over 2. So what we do is take just the argument now, and we say the argument 2x equals 3 pi over 2. Because this is the sine function, we want to write plus 2 pi k. We do that because the only way to get back to having a sine value of -1 is to do a full revolution, however many times. You could go in the positive direction or the negative direction, and the k stands for how many times you were doing the revolution. So this is the solution for all of the angles that would have a sine 2x equal -1. What we want to do now is finish solving this for x. So we are going to divide by 2, but remember, dividing by 2 is also the same as multiplying by 1/2. I'm going to choose to do that because I have a fraction, 3 pi over 2, on the right side, and dividing by 2 is going to look awkward. So we are going to take each one of these terms times 1/2, because whatever you do on one term of an equation, you must do on all terms of the equation. What happens then is on the left side, we now just have x. 3 pi over 2 times 1/2 gives me 3 pi over 4. 2 pi k times 1/2 just gives me pi k. So this is the solution that would give us all the angles that would work. We want only the angles that are between 0 and 2 pi. Right now I have 3 pi over 4 plus pi k. What will be helpful is if we rewrite pi k, remember that that is actually just a 1 pi. So to get a common denominator, I'm going to write it as 4 over 4 k. This means then that my first solution is the 3 pi over 4. What I have to do then is start adding 4 over 4 pi until I hit an angle measure that's more than 2 pi. So 3/4 pi plus 4/4 pi gives me 7/4 pi. And that is still less than 2. 7 over 4 is less than 2. But remember that 8 over 4 would equal 2. So if I added another 4/4 to that 7/4, I would be at 11/4, which is too big. So my only possible answers then are the 3 pi over 4 and the 7 pi over 4. For problem I, we have the square root of 3 times the tangent of 2x plus 1 equals 0. Just like we learned earlier, we need to get the function by itself. So the first thing we're going to do is subtract 1 on both sides. Now we will have the square root of 3 times the tangent of 2x equals -1. We still don't have the function by itself, so we need to divide both sides by the square root of 3. This gives us tangent 2x equals -1 over square root of 3. Now we have the function alone. As soon as the function is alone, you need to look for what angle this happens for. Remember that tangent is negative in quadrants 2 and 4. We really only need to look at quadrant 2. Because tangent is the same, cotangent works the same way. Because they are the same in diagonal quadrants, when you want to find all the angles, you just add plus pi k, because pi takes you halfway around the circle, and going diagonally is halfway around the circle. So we only need to look in the first negative quadrant, quadrant 2. Where is tangent equal to -1 over square root of 3? If you put the y coordinate over the x coordinate, where would that happen? That would happen at 5 pi over 6. So the angle where this happens is 5 pi over 6. Remember that at this point we write argument equals the angle. Then we have to check what function is this. This was tangent, so we're going to add pi k because it's the tangent function and we only need to go halfway around. We don't have to make a full revolution to get back to the same value. So once you have this, now you're ready to solve for x. And just like on the last problem, because this is 2x, we need to divide by 2 or multiply by 1/2. So we are going to multiply every term by 1/2. 2x times 1/2 leaves us with just x. 5 pi over 6 times 1/2 gives us 5 pi over 12. And 1/2 times pi k just gives us 1/2 pi k. Or you could write it as pi over 2k. Either one is fine. They mean exactly the same thing. This statement gives us all the solutions. We only want the solutions between 0 and 2 pi. To help us out, we're going to get a common denominator, so we're going to leave 5 pi over 12 alone, but 1/2 is the same thing as 6/12. So we're going to change that to plus 6 pi over 12k. That means then our first solution is always the first angle that you came up with, 5 pi over 12. For your second solution, add the fraction. 5 pi over 12 plus 6 pi over 12 gives me 11 pi over 12. That's not quite 1. We can't get to 2. So add another 6 pi over 12 to the answer you just got. 6 plus 11 puts me at 17 pi over 12. Keep in mind that to be 2, it would have to be 24 over 12. So 17 over 12 is fine. Try again, see what happens. 6 plus 17 puts me at 23 pi over 12, which is not quite 2, but it's very, very close. So I know right now that if I added one more, I would be too big. So in this case, we wound up with 4 solutions to this problem. Problem J has the equation cosecant of 2x equals the square root of 2. Remember that cosecant is the reciprocal of sine. So we could rewrite this as the sine of 2x equals 1 over square root of 2. Using either one of these equations is absolutely fine. It's already solved for the function, so we can go straight to looking at the unit circle. And if you think about it, anytime we have a square root of 2, it has to be a 45-degree angle. So the first place where the sign is positive, and you would have 1 over square root of 2, which becomes, remember, square root of 2 over 2, is at pi over 4. So the first place that this happens is in quadrant 1, and we write argument equals the angle pi over 4. Because this function is a sine or cosecant, we have to add 2 pi k for all possible solutions. There is a second quadrant in which the sign is positive. That's in quadrant 2. So we also have to include that angle, which means we have another equation where we say argument equals the other angle in quadrant 2, which is 3 pi over 4. And we still have to have the plus 2 pi k because it is the sine function. Now that we have argument equals angle, we're ready to solve for the argument. So we are going to take every term times 1/2. This will give us x equals pi over 8 this time plus pi k. We could rewrite this as pi over 8 plus 8 over 8 pi k. So our first angle is the pi over 8. For our second angle, we're going to add 8 over 8 to 1 over 8. That's going to give me 9 pi over 8. and then add again to see where you get. 9 pi over 8 plus 8 pi over 8 would give me 17 over 8. That's too big because 2 would be 16 over 8. So for the first quadrant angle, we get 2 solutions. Now go down and solve the second equation exactly the same way. Take the entire equation, every term, times 1/2. You will have x equals 3 pi over 8 plus pi k. So this one will become 3 pi over 8 plus 8 pi over 8 k. Our first solution is 3 pi over 8. Now add 8 to that. 3 plus 8 puts you at 11 pi over 8. For a second solution, add another 8 over 8. That would put you at 19 over 8, which is too big, so you stop. So you get 2 solutions out of this one also. On the next example, we have 2 times the cosine of x over 2 plus 1 equals 0. Like always, we need to get the function by itself, so we're going to subtract 1, and now have 2 times the cosine of x over 2 equals -1. We still don't have the function by itself, so we're going to divide by 2, and now have the cosine of x over 2 equals -1/2. Since we have function equals number, we're going to go to the unit circle and look for where the cosine equals -1/2. Cosine is negative in quadrants 2 and 3. The first place where the cosine is -1/2 is at the angle 2 pi over 3. So we're going to write x over 2, argument equals the angle 2 pi over 3. And because it was a cosine function, we're going to say plus 2 pi k. Our second equation will say argument equals the quadrant 3 angle, where cosine is 1/2, is 4 pi over 3. And again, plus 2 pi k. This one's a little bit different because instead of dividing by 2, and the numbers are not always going to be 2's, we're going to multiply everything by 2 on both equations to solve for that x. So the first equation will become x equals 4 pi over 3 plus 4 pi k. So we know that our first angle measure is the 4 pi over 3. To get an additional angle, we would have to add 4 pi. But we want all of our answers to be less than 2 pi. So adding 4 pi is too much. So we only get one solution for this one, 4 pi over 3. Do the same thing on the second equation. You will have x equals 8 pi over 3 plus 4 pi k. 8 pi over 3 is already bigger than 2 pi. So this solution does not exist. The only possible answer is 4 pi over 3. On example 5, letters L and M, you are going to be given function equals a fraction. The first thing that you're going to do on this type of problem is use your calculator and your inverse function to find what angle has that given function value. Once you do that, you're going to set up reference angles in the quadrants where the function would have that original sign, positive or negative. And then you're going to find what angles have those reference angles. And your answer should be in radians. So all your work, make sure your calculator is set in radians. On example letter L, we are given the secant of theta equals 5/2. Our calculator only does sine, cosine, tangent. So it's going to make it a whole lot easier if you rewrite this as a cosine. Remember that secant is the reciprocal of cosine. So if the secant is 5/2, what that means then is that the cosine of theta is 2/5. So when we go to our calculator, we're going to do the inverse cosine of 2/5 to get our theta and get a theta of 1.16 radians. Remember to keep your calculator in radians. So now let's think about where is cosine positive. Cosine is positive in the first quadrant and in the fourth quadrant. So our first angle will be in the first quadrant and it needs to have a reference angle of 1.16. Our other possible answer will be in the fourth quadrant and it needs to have a reference angle of 1.16. Your first answer then is, what's this angle measure? Well, from 0 to that line is 1.16. So our first angle is 1.16. Our second angle starts at 0 and comes over to here because we want between 0 and 2 pi. We want positive angle measures. In order to figure out what this distance is, we didn't quite make it to 2 pi. Since we are lacking 2 pi by 1.16 radians, to figure out our second angle measure, we're going to take 2 pi minus 1.16. Doing this on your calculator will give you your second possible angle measure, which is 5.12, and both of these angles are in radians. Example M gives us the equation of cosecant of theta equals negative 6/5. The first thing we want to do is rewrite this as the sine of theta equals negative 5/6. Then we're going to do this on our calculator, and to figure out what theta is, we have to do the inverse sine of negative 5/6 to get theta. In doing that, we get theta equals negative 0.985. Negative 0.985 would drop down into quadrant 4. So let's sketch where that would be. Our theta is negative 0.985. Remember, we want to know our reference angles. A quick review on reference angles. When your angle has dropped down into the fourth quadrant, remember your reference angle is from where you stopped back to the x. So our reference angle, which we symbolized as theta prime, is positive 0.985. That's the distance from where we ended back to the x. So the reference angle we want is 0.985. Now we have to think about where are sine and cosecant going to be negative. That happens in quadrant 3 and in quadrant 4. So in quadrant 3, we have to have a reference angle of 0.985. that means that our angle measure that we are looking for is what is it from 0 to where we stopped. Well, if you think about it, from 0 to the x-axis is pi, and then we went a little bit more past that pi. So our answer, our first theta, is pi plus the reference angle 0.985. Doing that on your calculator gets you 4.13. For the second angle, remember, sine is negative also in the fourth quadrant, and we want a reference angle, a theta prime, of 0.985. But our answer that we are looking for is what's the angle measure that starts at 0 and ends at the line of our reference angle. Anytime you are into the fourth quadrant, you haven't quite gotten to 2 pi. So your angle measure is going to be 2 pi minus that little bit that you didn't quite get to, and then that would give you 5.3, and both of these are in radians.